First of all, I'll just say this is a program that I wrote while I was camping at Paint Creek State Park. It's not very long. And it's entitled The Nash Equilibrium. So let's take a look. John Nash, who was the featured character in the movie A Beautiful Mind, by the age of 21 had already discovered a principle of game theory which he called the Nash equilibrium. His discovery was that every game that has a finite number of players has an equilibrium point, which was a stable condition, almost an agreement among all of the players, although it was more an individual decision by each player having surveyed the responses of all the players to each other. It was a position beyond which no player would wish to move. If each of the players could have arrived at a point that they would not wish to change, because changing would give them no further advantage in the game. And when they all come to that same conclusion, that's the Nash equilibrium. So, this program attempts to find one for 3 players. They are blue, red, and green. And the Nash equilibrium in this program will be the length of a single step. And that step is a very special step because it has to walk through each of these 13 lines below, taking an exact number of steps that completes each line without exceeding or falling short of that line's length. In other words, 6 has to fit into each line exactly. So 6 is a divisor, and the first thing I had the program do was find all the divisors for all 13 lines and find a common one. And what it found was that 6 was a common denominator of all 13 line lengths. So this diagram will show how many steps it took for each of the 13 lines. And for 192, that's pixels in length, it required 32 steps exactly. And for 90, 15 steps. And for 102, 17 steps. And for 36, obviously, 6 into 36, 6 steps. And that's it. That's the Nash equilibrium. I thank you for watching and have an excellent new year.